Can you hear me? Okay, thank you. Okay, welcome everyone to this course. This course is about the storage system architecture. So today is the first class of this course. So actually today, so I will introduce about this storage system architecture course. So today's course will end early. Okay, so I believe this 12 students registered this course, but to now we have 10 students now. Okay, so it's rainy. It's rainy and it's somewhat early for graduate students. So I believe some students are a little bit late. Okay, I will start. So this is the this is the storage system architecture course. So actually, this course is newly built for this semester. So the goal of this course is to explore the modern, it's a modern storage system architecture. So actually, my major is computer architecture, and then so normally the computer architecture include some area up to the main memory, like there's a process architecture, the process microarchitecture, and then cache hierarchy and main memory. Because so usually the computer hardware just manage up to main memory, but recently, and then the storage system, actually the SSD, solid state drives, or hard disk drive, HDD, are managed by operating systems. So that is the area of the operating systems. But recently, many computer architects focus on the storage systems because the criticality of the storage system is getting higher. So that means, so currently the computer systems need to handle large amount of data because today is the big data era. So many applications need to handle very large data, and then this data is stored in the storage systems. So actually, I believe everyone took the actually know about the computer architecture, the undergraduate level, and then I believe everyone took the undergraduate computer architecture course. Then I believe so everyone learned about the memory hierarchy. So in the memory hierarchy, the data is transferred to the register file, and then the processing engine just access the register file only. So the main purpose of the storage system is just store the data with the cheap cost, because actually the purpose of the secondary memory. So normally the storage system is called the secondary system memory. So the main purpose of this storage system is just store the user data, and then that is the persistent memory. That means that even though the power of the computer system is off, the data inside of this storage system is kept, so maintained. That is the persistent memory. But the data inside of the main memory is just wiped out because it's the volatile memory. So that purpose of the main purpose of the storage system is just store the user data with the cheap cost. And then this user data is maintained even though the power of the computer system is off. That is the main purpose. But I said the criticality is the importance of the storage system is getting higher because the size of the data grows exponentially. So actually the main purpose of what is the main purpose of the storage system? Just transfer data to the main memory if requested. And then if the data is stored in the main memory, the entire data is stored in the main memory, and then the data is accessed by computer processor like CPU or GPUs. And then this data is transferred to the register file, and then the instructions are executed inside of the processor, and that's it. But the data is, if the data size is the large, then the data is frequently requested to storage system. And then this data movement cost is currently is the cost is very high. So that's why currently the criticality of the storage system is very high. Okay, so that's why we are learning this storage system architecture in this semester. So what will be covered in this course? So actually, I'm the computer architect. So we will explore the architectural features of storage systems. So architectural features. So architectural feature means that is some architectural abstractions. So not the detail of the some semiconductor technology and then some property of the flash memory, something like that. Will not be covered during this course. So we need to briefly know about the property of the flash memory and then some very emerging memories, because these emerging memories will be widely deployed in the computer systems. So for example, flash memory. So then the flash memory is widely used as the storage medium. Okay. So if you want to study the storage system or some modern storage systems such as solid state drives, then we need to briefly, not a detail, briefly some property of this some emerging persistent non-volatile memories. Okay. So in this course, we will cover the basics of the storage systems. So actually, this basic of the storage system is the area of the operating system, but people diving into some research articles or research papers or research topics of the storage system, we will cover some basics of storage systems. And then in this course, we will focus on the solid state drives. SSD is called SSD, not HDD. Until now, we frequently use the hard disk drive because the cost of the cost of the hard disk drive is cheaper than other solid state drives or some solid state memories. It's a memory. So, but the disadvantage of the hard disk drive is that hard disk drive is a kind of mechanical devices. I said it's a mechanical. So that means hard disk drive has motor. So actually, if we learn also about the hard disk drive in this course, but if you see the inside of the hard disk drive has it's a flat platter. It's a kind of it looks like a dish. It's 접시. It's called the platter. And then the motor rotates the platter. So that's the kind of mechanical systems. But most of the component inside of the computer systems is chips. They are chips. That means it's the semiconductor devices. So advantage of the semiconductor device is that if we just give some electric signals as the control signal or data, then with some fixed latency, the output is solved from these semiconductor devices. That is the advantage of the semi-electric devices or semiconductor devices. But mechanical devices, so mechanical device just rotate the motors. So the latency of this hard disk drive varies by situation. That is the disadvantage. Also, it's very slow. It's very slow, much slower than the semiconductor device. That is the disadvantage of the hard disk drive. So recently, many computer architects or computer architecture researchers focus on this solid state drives. Okay, so we will in this course we will focus on the solid state drives. So and then in the inside of the solid state drives, flash memory is used for primary storage media. So we just focus on the flash memory. So we briefly learn about some characteristics of flash memory in this course. So and then we will learn about the SSD architecture. So SSD is the kind of some computer system. So that means the SSD has the processor. It's called the SSD processor or application processors. And then this application processor runs software. It's a system software called firmware. And then also SSD is composed of some memory systems and then flash memory. So it's a hardware. So we will learn about the SSD architecture, like firmware and hardware of the SSD. And then due to some unique characteristics of flash memory, this flash memory should be managed by firmware and hardware of the SSD. And then this firmware this layer, some software or hardware, is called the flash memory, flash translation layer, FTL. So we will learn about the flash memory management. And then we will also explore the area of in storage processing. So I believe some of you have heard about the near data processing. So near data processing means that the processing engine is located close to data. So advantage of this model is to reduce the cost of data movement. And then this near data processing model can be applied to the storage also. So, and then this model is called the in-storage processing. So we will explore this in-storage processing. And then this is the architecture course. And then we can also work with the real hardware or real development system, but also we can work with the simulator. So these simulators emulate the behavior of the storage system. So we will learn about some storage system simulators. Okay. So I will mainly use lecture slides like some my other graduate courses. So hopefully I will post the lecture slides before each class. And then this is the graduate course. So we will also read some research papers regarding storage system architecture. So these are the main materials we will use for this course. And then for the some what's that? Is the some introduction to the some storage system. So we will use this textbook. It's the operating system 3 easy pieces. So if you visit this site ostep.org, then you can find the free PDF file for this operating system books. So the author of this book, authors, because there are 2 authors. The authors of this book generously upload their the PDF each chapter of PDF file for this textbook on this site. So you can easily access these articles. And then research papers, we will use the architectural simulators. And then me, instructor, my name is Konje Ku, Konje. And then my office is at Ujong Jongbogan, the whole Ujong Informatics, whole of Ujong Informatics, office number 43. And then if you have any questions or issues, you can email me with this email address. And this is my website, and then this is my web page. So if you have interest in my research area or computer architecture or some other storage system architecture, then you can visit my web page, or you can visit my lab page here. And my research area generally computer architecture. So it's a low level of the computer engineering department. It's the kind of a hardware and software interface. And then currently I'm focusing on memory storage systems and neural network accelerators and GPU architecture and RISC-V architectures. So, and then cursor page. So we will use the Blackboard. So Blackboard provided by Korea University. And then, so I will use the Blackboard for posting announcement, assignment, and then project, and then possibly exams. And then lecture slides and videos. So I plan to post the lecture slides and videos on Piazza, not this Blackboard. So, and then we will use the Piazza. The Piazza is the class management tool. It's a site, class management site. And then this is the site address of this course on Piazza. And then you need to sign up as students. So this is the sign up code, the store architect join as a student. So I will use this Piazza for class management and the discussion, and then you can post any questions, any issues on Piazza. Also, I will post my lecture slides, and then I will also post the link of the videos, lecture videos. So this lecture, actually due to the COVID-19 pandemic, so we need to use the Zoom until the midterm period. So this lecture will be automatically recorded by Zoom. So, and then for your convenience, I will post this recorded video on the YouTube, and then I will also post the link of this YouTube video on the Piazza, not Blackboard. So I will not use okay. So I captured the Blackboard here, and then you can find the Zoom classroom here. Then if you click this link, then you can enter the Zoom classroom, this room. And so I made a link for Piazza here. So if you click on this Piazza, then you can go to the Piazza. And then resources are it's a resource tab of the Piazza. So I will share my okay. So this is the Blackboard. I believe everyone can see my Chrome browser. So if you click the resources here, then you can find the resource tab of the Piazza. And then I will post the lecture note here, the lecture videos here, and then I also post some papers, such general resources here, and then homework, solution. So I will post just the lecture video, no lecture notes and the videos only on Piazza, not Blackboard. Okay, so please frequently visit the Piazza site before each class. Okay. Yeah, so unfortunately, we are in the COVID-19 pandemic, so, and then the situation is getting severe, unfortunately. So we need to use the Zoom. This is the Zoom information. So actually, I believe everyone needed to register for this class because, and then you need to input your student ID and your names for each registration. So I will use this information for attendance check. So please input your correct student ID. And the recommendation is that, so please turn on your video camera. It's a recommendation, not it's just a recommendation because so it's a Zoom class. The problem of the Zoom class is that so it's not easy to focus on the class or lectures. So and then I understand that, but I believe if you turn on the video, then I believe you can focus on the lectures. More you can more focus on the lectures. Okay, it's just a recommendation, and just do not waste the this lecture time. Just focus on the lectures. Okay. So grading policy. So it's a tentative policies. We will take the midterm exam, and then also we will have the term project. And then for the term project, we will use some architectural simulators. Okay. And if possible, then you can use the real development platform, if possible, or you can use the real storage devices like SSD or hard disk drive. Okay, and then there will be some homework assignments, and then attendance is 5%. And the exam, on-site exam, I plan the on-site exam. It's a closed book, and then this is the English course, so I will use the English during the classes, but you can, the Korean students, so you can use you can ask a question in Korean, also you can use Korean. So using English is my duty, so teaching in English is my duty, but it's not your duty. So, and also that is also same, is also the same to the exam. So you can answer in Korean, okay? Also, you can answer in English. It's a schedule. It's some. It's a 15 weeks course. So it's some tentative schedule. Okay. And then the class will be canceled during Chuseok holidays. It's on September 21st. So that's why we have 15 weeks for this course. Okay. Okay. Do you have any questions about the some course or in syllabus? So I promise I will finish this today's class early. I will briefly explain about some storage system and then memory hierarchy, and then the level of the storage system inside of the memory hierarchy. So this is the memory hierarchy. So why do we use memory hierarchy? The first reason is that we do not have ideal memories. So what is the ideal memory? Ideal memory means it's a fast memory, so latency is low. Also, its density is high. So that means that in the same area, more data should be stored. That means the density is the high. Density is high. So that is the ideal memory, and then also the price is cheap. The cost is cheap, but we do not have an ideal memory. So that's why we need to have memory hierarchy like this. So for this memory hierarchy, we have the register file and then caches and the main memory like DRAM and then storage systems. For the cache has the highest performance or among these memory hierarchies, memory levels, because cache has the cache use the as RAM cells. So it's a static RAM, and then static RAM has the very high performance. That means it's a fast. But the size of this register file is very small, so it's the lowest capacity. But if we just focus on the storage, so cost is low and then performance is also low, but capacity is high. So that's why we use the hard disk drive or solid state drive as the storage systems. So, but storage system is the lowest part of this memory hierarchy, it's the lowest level. So this storage is just store the large amount of data. And then if data is requested by processor, it's a CPU, then the data is transferred to the main memory. And then some requested data is transferred to the multi-level caches. And then this data is transferred to the register file. So we use the load instruction to request data. Okay, like load R1, 0, R2. So this is the address, this is the target register file. So it's just the load instruction just requests this data for the target register file. But if this target data does not exist in the main memory, then the data is requested from the storage. Okay. Also, we manage our user data in the storage as files actually. So the files operating system runs the file systems. So file FS is the file system. So actually, if we when we create our own program, and then if we want to use the data inside of this storage system, we firstly access the file. Okay, file on the storage system, like with the open command. And then if the file is open, then the data inside of the file is transferred to the main memory. Okay. And then the computer processor accesses this data inside of the main memory. So that's how our application works with the memory hierarchy and then storage system. And what's the problem? As I explained, when the data is requested by some applications, then data should be transferred from the storage system. If this data does not exist in main memory or cache memories, then the data is requested from the storage system, and then it will take very long time. But why can you use this memory hierarchy? Because data has localities, temporal locality and spatial locality. So that means that if the data is requested by some applications, the same data or the neighbor data will be frequently, and then will be frequently re-accessed and then re-requested by these applications. That is the locality. So memory hierarchy exploit the data locality. Okay. The problem is that as the data size increases, this data locality property is getting weaker. So that means large amount of data is requested to the storage system because one application requires large amount of data. Actually, conventional application just request the small amount of data, and then just this application just focus on this small amount of data. So conventional application. So but our big data applications like data analytics or database, also the machine learning applications handles the large amount of data. So this data cannot reside in the main memory. So this large amount of data is frequently requested by these big data applications. That means the storage system is frequently accessed by this type of applications. So what is the problem? The data should be read from the storage system and then transferred to the main memory and then transferred to the cache and then transferred to the register file. So we need to briefly know about the latency of each level of the memory hierarchy. So the latency of the register file is like some nanosecond, like the few nanoseconds. And then for the cache memory is like tens nanosecond or a few nanoseconds also, because cache also has the SRAM. But level 3 cache will have about the hundreds nanosecond of latency. And the main memory, the latency of the main memory is so like tens microsecond latency about the storage. For the SSD, it's about the tens, I don't know. Millisecond, it's microsecond, okay. But so the latency of the SSD is higher, about 1,000 times higher than the latency of the main memory, like it's a millisecond. Oh, I need to check. Okay, 100 nanosecond. Okay. So that means that the latency is about 1,000 times higher than the latency of the main memory. I need to check, but it's 1,000 times higher. So it's very, very slow. So if the data exists in the storage system, and then this data is required by application, so this data movement cost is very high. So, but computing unit is here. So that is the problem of the current big data applications. So that's why we need the near data processing concept. So actually the purpose of the near data processing is to reduce this data movement cost. So actually we, in this course, we'll also focus on the near data processing concept that is applied to the storage system. Okay, so data is huge. So this left photo shows the hard disk drive. So actually she captured the image of the black hole, and then in order to capture this image of the black hole, we need to have 700 terabyte of low data, and this is the hard disk drive that contains this 700 terabyte of data. So data size is very huge, and then actually the weight of this all hard disk drives is about half ton, and then the right photo shows the code book, and then she programmed the codes for space aircraft for NASA. So and then she printed her codes, and then this is the papers that had some codes. So that means this photo shows that data is large. The amount of data is large. So and then for this, in order to process this large amount of data, then we need to focus on the storage system, the performance of storage systems. Okay. Also, this graph shows the amount of created data every year, and then we are here about the 60 zettabyte, but in 5 years it will become 160 zettabyte. It's a very large. So we don't know about the zetta. It's a very it's a tera, peta, and maybe zetta. So that means the data is the large amount of data is created every day. And YouTube. So for YouTube, so everyone in the world posts their videos to the YouTube. So this created data, so amount of created data is very huge. So we live in the big data era, and then in the big data era, storage system is critical. So that's why we need to focus on the storage system. So this table shows the processing by I/O ratio in the data center SSD, and then I take this data from the summarized paper. It's a micro paper. So and then this is the data set, and then also this is the application. So TPCH is the benchmark application for the query applications, and then so TPCH query 6, 1, 14, just to implement some example query processing for database systems. So, and then this number represents the ratio of the IO processing by IO ratio. So that means that 0.42 means that if the processing time is 1, then IO time is the 0.42. So entire execution time is the 1.42. So as you can see, this IO time ratio is very high for the data analytics applications, like 0.42, and then for the query 1, so this ratio is over 1. So that means the data IO time is longer than the processing time. So this is the raw data actually, not some real database management systems. So actually, in order to reduce this IO time, commodity database management system use the many techniques such as the index structures or some caches or something like that. But we just measure the raw data. So data transfer from the storage system and then the data processing by CPUs. So if we just focus on the raw data transfers from the storage system, the processing, this I/O time is very high. That's why we need to focus on this data movement cost from the storage system. It's very high compared to the processing time. It's because the conventionally storage system is very, very slow compared to the main memory and the cache memories, but large amount of data is stored in the storage system. And then the size of data is increasing exponentially. That is the current problem of our big data applications, also big data systems. So data movement is critical issues. So this is the very very good research topics because data movement is just now critical. So we need to focus on this storage system and then data movement cost and then data movement inside of the memory hierarchy. Okay, that's why we will learn about the storage system architecture. Okay, so I will stop here as I promised. So and then in the next class we will learn about some basics of the storage systems, hard disk drive, and file systems. So as I mentioned, there's some area of the operating systems. So please read these chapters. So operating systems, 3 easy pieces, and then I will cover these chapters. So chapter number 35 to 40. So please read before the next class. Okay. Okay. I stop here because this is it's the first class of this course. So, and do you have any questions? Okay. If you do not have any questions, so I will stop here. Okay. Thank you for listening, and then let's see you the next week.